Hi everyone, I just wanted to take a look at one of the examples from the homework, practice questions from the homework. This is an example of a limit as x approaches 8 of x minus 8 over third root of x minus 2. Now this limit is indeterminate because if you substitute x by 8, then you're going to get 8 minus 8, which is 0, and then the third root of 8 would be 2 minus 2 is also 0. So 0 over 0 is undefined, which makes this an indeterminate form limit. So we estimate this or evaluate these limits by using what we call the factoring technique. But I took this as an example because it may be a little bit more difficult for us to see what the factors or how to factor this particular rational expression or rational function. So when you think about it, so I'm going to rewrite here the limit as x approaches 8. Okay, and down in the denominator is we have the third root of x minus 2, which became 0 at x equals 8. So what that means is that x minus 8 can be a factor in the denominator, but it's kind of hard for us to see it. So I'm going to rewrite this entire expression a little bit differently. So I'm going to start off with the denominator because that's the source of all the, troubles. So instead of the third root of x, I'll write it as x to the power 1 over 3 and then minus 2. So now I am going to move on to the numerator, and I'm going to try to make the numerator resemble, or the terms in the numerator resemble the terms in the denominator so that I can somehow simplify in one way or another. So you probably recognize that number 8 is a perfect cube number, which means that it can be written or it can be connected with the number 2 that we see here in the denominator brought to the power of 3. And since we're talking about powers of 3 here, we will rewrite the x as a power of 3 as well. But remember that we cannot change the value of the term, which means that we need to modify the term x. And if we want the power of 3, we need to give x the power of 1 over 3. So in this way, we still have x to the power of 1 because 1 over 3 times 3 is 1. So at this point in time, we are going to again focus on the numerator. Denominator terms are quite small, not so easy to simplify or to break down the very small numbers or terms. So we'll focus on the numerator. So as you can see here, we have the difference of two cubic terms. So, or the difference of cubes. We have learned the formula for the factors of difference of cubes. We know that the factored form would be a minus b, and then the other factor is a squared plus ab plus b squared. Okay, now again, I just want to reinforce the fact that this does look like a quadratic, perfect square trinomial, but it doesn't have the 2 in here in the middle term, which makes this factor unfactorable. So you cannot break this down any further because I get this question asked all the time is, can we factor this more? The answer is no, never. Okay, so let's use that formula, that same formula to factor what we have here in the numerator. So we have the limit as x approaches 8. And we have a long fraction here. So remember that our a value, so we have to the power of 3, we have brought x to the 1 over 3. So that's our a value. So it means we have x to the power of 1 over 3 minus our b here would be number 2. So minus 2 in brackets. And the other factor will be the first term, x to the power 1 over 3 squared, and then plus the product of the two terms, which is x times to the power 1 over 3 times 2. And then the last term, which is 2 squared. And we'll close the brackets down here. And then in the denominator, we have x to the 1 over 3 minus 2. We said we cannot do much about it. And as you can see, we have actually a common factor in both numerator and denominator. And look at our limit now. So beautiful. So we have x to the power of 2 over 3. Remember, we multiply the powers, the power law, right? And then plus, plus 2x to the power of 1 over 3, and then plus 4. It seems that our expression is now ready to be evaluated at 8. Let's see what we obtain here. We have 8 to the power of 2 over 3, and then plus 2 times 8 to the power of 1 over 3, and then plus 4. Now, remember that 8 to the power of 1 over 3 is the cubic root of 8. That's a 2. You square it, you get a 4. Or you can simply use the calculator. But whenever given a chance, try to use, your reasoning. So try to do mental math as much as possible. It keeps your brain alert. And it keeps your brain alert. So 2 times 2, that's another 4. And then we have another 4 in here. And the 3/4 will make a 12, and that would be the value of the limit of the function at this point. And again, if you want to check your answer with Desmos, just simply try to graph this function on Desmos and check and see what the value of it would be around 8. So why don't we do this together now? So we have y equals, so the numerator had x minus 8, and the denominator has divided by, so we have x to the power of, we said 1 over 3. I'm going to write the power 1 over 3 instead of the root, the third root, and then we had minus 2. Okay, so this is the graph, quite beautiful, isn't it? And we were trying to estimate this at 8. Estimate the value of a function at 8. Let's go at x equals 8, see what happens. What exactly is going on here? So first I want you to think what is supposed to happen here at x equals 8. You got it, a whole, right? So we have a whole, so which means that the function is undefined at 8. We saw this because we substituted x by 8 at the very beginning before evaluating the limit. It didn't work out. But the limit exists because the tendency in the y values in here at x equals 8 will be around 12. So the value of the limit, or the value of the function, would have been 8. It would have been 12 at x equals 8. Okay, so I hope this made sense again, and thank you for watching. Bye for now.